I started this, okay. Yeah, that's good.
Okay, you want good news or bad news first?
Bad.
Bad news first.
Bad news is we're not done with school yet. Okay, so I was grading your test and I got like halfway done, and I'm like, why am I grading these? Because I don't know what's going to happen when I go to IU on Wednesday. Okay? So there's a chance that I'm going to have to turn in your test because I have to for pre-calc. And if I do that, I can't turn in tests that you guys use open note, open book, and shared stuff on. So I'm either going to A, have to re-give you the same test, or B, they're going to give me abilities to create my own, or if I don't have to turn it in, it's not that big of a deal, okay? So I wanted to wait because I don't want to hand it back to you guys if you're going to have to redo the same one, but I do want to teach about whatever the stuff that you are struggling with. So some of you are still struggling with how to do the limit formula, that's the derivative. Half-life was a big struggle, inverses was a big struggle, and then I stopped after that. I didn't go further, okay? Because I don't know what to do until I meet with them on Wednesday, so then I want to talk about that on Thursday, okay? Second thing that possibly is good news, I'm going to ask Mr. Allen if I cannot give you guys a final exam today. Here's why. I would rather use that time to teach and review things that you're still struggling with from that test. So here's what I'm thinking in my head, and I'm going to listen to what IU tells me on Wednesday. My thought process was, don't give a final exam, reteach the stuff, come back in January, finish reteaching with the new stuff we're doing, and then give you the official first test, like the second or third week of January. That's my thought process. That's what I'm thinking. I was going to text Michelle last night, and I was like, no, I'm just going to talk to him in person today, because I'm like, you guys aren't really going to care. I didn't think you were really going to care. So I want to know what IU says I have to do first before I, like, here's what I don't know. I don't know if it was a test that she said that they had to give, or if it's like what pre-calc does for me. Here's what we give. You can write your own based on these are the kinds of questions. The second one?
Yeah,
Okay.
I'm pretty
Because
sure she said it.
I can write my own test for pre-calc except for the final exam. So I don't know what calculus rules are, if that makes sense. And I
I'm
don't
pretty
want.
sure it's the same.
Okay, so she just gave whatever they did instead of rewriting her own. Probably. Okay. Good news. You guys only have to come before school 2 more days.
Yeah.
Is that good news?
Yeah, we don't have to come Friday. We have our Friday.
Tomorrow, you're going to come early. Wednesday, you're not because I'm not here. Okay? I'm going on IU. Thursday, you're going to come early. And then Friday, we start final exams.
Wait, hang on.
Do for our final, you're giving the final to the and you want to teach us.
Yeah, that sounds
Okay,
good.
so I'm going to ask if Mr. Irvin can cover my pre-calc class. Like get them started on their final, he comes and covers it, and then I go over there and teach.
Okay.
Or we go to the MTT room and teach if he thinks it's gonna be too loud.
Teach us.
Mhm.
No, teach pre-calc, calculus.
Yeah, that's what I'm gonna ask. You think that's a good idea? Bad idea?
How do they feel about this? You're like,
Sorry.
how do they feel about this review?
IU?
No, you're.
Pre-calc.
They're not happy.
Yeah.
They always complain.
They feel like I'm pouring too many directions.
Where you are.
They don't know about this idea because I was thinking about it yesterday when I'm grading your assist test. And I'm like, how can I go through all this before Friday? So I was like, oh, maybe I don't have to. Okay, good news, besides that you only have to come in 2 more days early, is I have everything else graded.
I was so
And it's
mad.
Christmas 10th.
And it's Christmas.
I had to work yesterday, and my manager was like, don't forget we have a team meeting Wednesday. And I'm like, you're kidding. The one day, like, I'm looking forward so much Wednesday that I get to sleep in until at least, like, 6 or something. And then I have to be up at 4:30 to be there at 6.
I'm sorry.
It's so frustrating. I want to be done.
I don't want to just because I know that I'm going to be sent down because that's what I'm going to do.
You're not correct on it.
What, me?
Would you rather hurt?
Good try.
I don't think it's that.
Try, good try.
Some of you like think that you can do math rules that are not allowed. So that's why I have to put not correct, because you can't like do that.
You don't math right.
You thought about the, what was that one word you said that one time?
I don't know.
Grammatic or?
I'm grammatically correct.
Not grammatically correct.
I thought she said not grammarly.
Yeah.
I don't really know what she said, but it was funny.
Can't grammarly properly or something.
No, I was trying to say mathematically correct and it.
Oh, you said.
Grammatically.
So if we don't have a final, that's honestly gonna make my heart happy and less stressful.
Okay.
Your heart is gonna
You
be
have a
less stressed.
you have a stressed heart?
Yes, I
You should probably go get like a pacemaker.
I'm just gonna be real with you. It's really not my call. I have to do what my boss says.
Carly, got any persuasion?
Okay, if you missed any points on the homework, it's because you didn't do a problem. So if you find that you did it and I haven't marked down that you didn't do it, please show me.
In the library.
Because at 10 o'clock last night, I was over grading. Over it. Okay?
I feel,
Well, thank you.
that was cool.
So I'm sure you probably felt the same way like on doing the homework. Like you get over it and then you're just like, I'm not doing this anymore. Okay, do you guys want to know the answers to the quiz? The correct answers?
I'm good.
You're-
I do.
Shut up there, Lucas.
I think
Why
it
did
was
I do
like
that?
75 or 80. Somebody else did the same one.
I was just not thinking.
It's I.
I did this wrong
It was
because
one
I
of the
switched
last
that.
ones.
I got
Okay.
the Y or
Oh,
the
I'm
X
stupid.
instead of that instead of Y.
Okay, so I've updated everyone's grade, and not everybody has 100% anymore because some people haven't turned in the homework. Hint, hint, those of you watching the video. Okay?
Added.
Boom, roasted.
So roasted.
For athletes, did she already put that in her? Because we've done it twice now.
I
Yeah.
have the most current one. I don't know about the previous one.
We've
The
done
most
this,
current one I have not
done
put
too.
in there.
There's only two.
I think everybody.
And Mr. Bennett did give me all the calculus kits for that. It's sitting over there in a pile underneath the yellow paper.
That big pile right there.
No, underneath my keys.
Oh,
my God.
I was like, jeez, oh.
Do you want me to see if you're in here?
Geese? No. Yeah, sure.
I also have ISEP scores that are here too. This don't apply to you. Okay, so here's who I have from calculus. Hannah Floyd, Lucas, Ruthie,
How I did that.
Faith,
Math.
Carly, and that's it. Is that correct? Does anyone think they did math league last time? I don't know about the time before.
I didn't do it.
I even think the people not watching the video did it too.
You
The
do
time
think?
before, yeah.
The time before? Okay.
But
I
she
think-
gave us them.
Would it have been,
Yeah, she gave us all of them, like all of us got ones.
Yeah.
Yeah, like we
Right,
didn't
but
go
was-
there. She handed them to us.
was it on last time week's grade?
No.
I don't think so.
Okay, I'll go through the stuff in her room and see if I can find it. Do I need to go over the answers to the quiz? Anybody? If you want to see it, I have it. How do you feel about this stuff? Most of you, I feel like either get it or don't get it. If you don't get it, do you know why you messed up?
Yes.
Maybe? Yes? Yes? No? Okay. Do we try the proofs that you didn't want to do? I don't even know what number they were,
I
like
did 'em.
30 or 34 or 35, 36, the homework.
Except for 51, I didn't do that. I think it was 41, the one that you were talking about.
41. How about we'll do part A together, then you can do B and C on your own. Does that sound fair? Because essentially you're gonna use the same thing. Now you're gonna want your books open because I'm gonna reference like what where the formulas are in your book.
Are you sure you don't care if this is out of order?
It's really hard when it's out of order to grade, but I mean, if it needs to be out of order, that's okay.
Yeah, me too.
Just
Why
leave
don't you
spaces.
Why don't you just write the ones that we go over on a separate sheet of
That's
paper?
what I did. I do them in my notes and then I.
Or why don't you just leave space for the next one?
And then rewrite them over.
That takes too much time.
Oh.
Whenever
agree
we're
with
doing
you.
41.
I think this is what it was. Is that 41A? Well, it says it says prove 18A. Is that what 18A is?
Yes. Yes.
Okay, so if you're proving this, you can use any of the formulas before it. Okay, so I want you to go to 12 and 13. The formula is 12 and 13, which would be on page. Keep going.
Are those sum and difference formulas?
Wait, no, not that far, sorry. You're not even gonna get appendix. Yes, so 12A, 12B, 13A, 13B, and 14A, 14B, okay? So, we're gonna prove, not from left to right, but prove that the right-hand side looks like the left-hand side. So 12 comes before 18, so we can use our sum and difference formulas.
A29.
Okay? Alright, so what do you know about, what is sine x plus y? What's that equal to?
Sine x cosine y
Okay.
plus cosine x sine y.
And that's from, is that 12A?
Let's see.
Plus u times 3.
I think that's from 12A.
Yes. Well,
Okay. So for 12A, you know that sine of x plus y, or if you're looking at your formula sheet, it's in the bottom left-hand corner. Okay? Then you know sine, this one right here, which we'll do here, which I think is 13A in your book.
Yeah.
Okay, so sine of x minus y is sine x cosine y minus cosine x sine y, correct? Okay. So this side right now will be a half, and then if I put that all together, sine x cosine y, and then we're adding the two formulas, so the signs would stay the same. If you're subtracting the two formulas, you would change the signs. Okay, then what can you do from there?
Cancel the cosine x sine y.
Okay, anything else?
Combine the sine x cosine
Okay, so I can combine those two together and cancel the other ones, right?
y. Right.
Okay, so these two, you can add together, and then those two cancel. So then I have a half. Well, if I have 1 plus 1, that's 2. And then what's 1/2 times 2? Isn't that what you wanted to prove? So you're done. Okay, so will that help you with B and C? Because you're using the same ones. Formulas 12, 13, and 14. On whatever, what page was that on?
A29. Or
Eight.
A29.
A29? What other questions do you have on the Appendix D homework? The only one I think you might have is 51 getting started, because this is a formula already. So I'm just gonna help you get started and then you can finish this. This is technically already a formula, but your goal is to prove that this formula is true. Kinda like what we did on 41A. So if I wanna prove that tangent of 2 theta is this, remember, if you have whatever you would have here, this is the same thing as tangent of theta plus theta? Because that would be 2 theta. And then you could use your sum and difference formulas down on the bottom left, or it's the same ones we just used for 41. Because tangent adding is tangent of the first plus tangent of the second over 1 minus those two multiplied together. And I'll let you finish the last step. Okay?
Get us started.
Yeah, I did like 90%.
Yeah.
Yeah, but most of you probably would have just put the answer from the formula instead of proving on the
Yeah,
formula.
that's what I did.
Okay? Because it is a formula, you do know your definition for this. Okay, any other questions on the appendix D? Do you think you guys don't have it done by tomorrow at the end of class, at the end of the day, or do you think you need Wednesday? Okay, let's try to turn it in tomorrow. If not, I need it by the end of the day Wednesday, so when I come back from IU, it's all turned in, okay? We're gonna move on to 3:30. Just think how much we've accomplished so far, guys. Are you feeling proud? Or not really?
Yes.
I'm feeling proud. You guys are a rock star in it.
I don't know if I did that far.
We have a great teacher.
I don't know about that. I'm a little in over my head. It's all good.
I'm just like really happy with all this government stuff.
Okay, so we're gonna talk about derivatives of trig functions. Okay, and I'm gonna kind of show you a loose proof on one of them, and then I'm just gonna tell you all of them, so that maybe you could find them if you wanted to using the product and quotient rule. Okay, but I'm assuming you would probably rather just memorize all the trig derivatives of the trig functions. Just like I said, the derivative of e to the x is e to the x. These are 6 that I would just memorize. Okay? Now, in order to be able to find a derivative, what 2 things have to exist? What 2 things have to be true?
Has to be.
Has to be continuous. Okay, so what does it mean in order for it to be differentiable? It means it has to be continuous and the limits have to approach the same number from both sides. Okay? So those are your 2 rules. So this is just a reminder, all trig functions are continuous at their domains. Okay? And then all their limits are going to approach the same number for whatever the trig function is at that number. So like sine and cosine are either going to approach 0, they're going to approach 1 or -1 depending on what the number is. Okay? But I want to make sure that you know, so we can find a derivative of all of these. Okay. So, for your first one, the derivative of sine is cosine. That's like, I'm going to box in like all the ones we get there, okay? Now, I'm gonna show you the proof, but there's two things in the proof I'm not gonna show you how to prove, I'm just gonna tell you that they're facts. Okay, so the first fact, which I'm just gonna number one, is the limit, let's just say as theta goes to 0, of sine theta over theta equals 1. And you will use this later in all, like the lessons today, okay? And then the other one we're gonna assume, like we know is true, and they do give you the proof. So if you wanna look at the proofs in your book, they are in there of how you get these. I would rather just show you the general proof.
So like these ones go with that, right?
These are just, this is the, like an actual, I'm gonna give you all the 6 trig functions, but in order to prove this, we have to know these 2 facts. But you have to know these 2 facts for part of your homework anyways. Okay, so if you're finding the sine, let's say you're finding the limit as theta goes to 0 of sine of 4x over 4x. If these numbers are the same and you're finding the limit as it goes to 0, this is always going to be 1. That's what this is saying. So no matter what your angle is, this angle, if you're dividing by that same number, whatever the angle is, your derivative or your limit as it goes to 0 will always be 1. Okay, just as a cosine, if it's cosine minus 1 divided by that angle, whatever the angle is, that's going to be 0. So if you want to look at those proofs, they're at the very beginning of section 3.3. But we're just gonna prove how you get the derivative of sine is cosine. I'm not gonna do the rest of the proofs unless you want to. Okay, so do you remember, which most of you did awesome on this, on your test, the derivative, or the limit as h goes to 0 of, is this how you find the derivative? Yes? Okay. So like we can review and do this all at the same time. Look at this, don't act so excited. Okay, so if I'm doing sine's my function, I'm trying to prove the derivative of sine's cosine, then that means the limit as h goes to 0 of sine of x plus h minus sine over h. That's what I have to find my derivative.
Well, these days I'm gonna get a cat. Where did I already?
We just talked about this on Friday. I'm sorry, what did you say?
Why did you put an H there like that?
Oh, I'm sorry, that should be sine x, not sine h.
What did we just talk about on Friday?
How much is this?
So, our tests are not great.
Yeah, but I'm currently teaching class, so come back later. If we're still doing stuff for student council, she's only came to like 2 meetings the last like 2 weeks, you know. Sorry. Too positive.
Well, at least she
I had to
remembered.
ask me who the girl was
At least
at
she
the last
remembered this.
2 meetings ago. Okay, so then if you know your sum and difference formulas, then we're going to use that, which was what we just did on 41A when we were proving, but on your paper, then the bottom left. Okay, so sine adding says you would do sine of the first, bless you, cosine of the second, bless you, plus cosine of the first, sine of the second, then I still have the minus sine x over h. Okay, now if you have 3 parts, can't you split it up into like 1, 2, and 3? Yes. Okay, now, do you see how this first part and the last part have sine x? I want to put those together. So I'm going to put those together. Okay, and then I'm going minus 1. You could put a separate limit. I'm just going to put this like this.
So are you getting these off of each other?
And I'm getting these off of, what do you mean?
Like, are you going like?
I was
I'm
like,
going
what
from here
the?
to here to here.
Yeah.
So I was,
I don't even know what you're asking.
I'm just really lost.
Okay, so I went from here to here.
Yeah.
This became this because of the formulas, your sum and difference formulas. So sine adding says you're going to do sine of the first, cosine of the second.
Oh, okay.
Okay? Then I went from this step to this step. I just put the parts that had sine x together and the part that had cosine x together. That's all I did. Okay? Okay. Then I'm gonna keep going down, Hannah. Is that okay with you?
Going off the
Okay.
other one.
Then if I do the first one, those both have a sine x. I'm gonna factor that out. And this is left with cosine h minus 1 over h. And I'm going to factor out a cosine out of this one because it doesn't have an h in it. Are you seeing anything cool that's going to happen?
Are you excited, Lucas?
It just kind of comes together nicely.
Okay, so I told you you're going to have to use these like 2 rules over here. So what's the limit if I have cosine h minus 1 over h? So if these were thetas,
0.
that's 0. So then this becomes
Sine of 0.
sine x times 0 plus, then I have cosine x times, well, what's sine h over h?
1.
1. So this would be 0 plus cosine, which is cosine, which is what we just proved. Now, I'm not going to prove all 6. Is that okay with you?
That's alright.
Yeah.
Okay. So you would prove cosine similarly how you would prove sine. The rest of those sine or tangent, the rest of them you would use the quotient rule. Okay? Alright, so if I'm just going to give it to you, so the derivative of cosine is negative sine. The derivative of tangent is secant squared. The derivative of cosecant, I don't know these by heart, is negative cosecant cotangent. The derivative of secant is secant tangent. And the derivative of cotangent is negative cosecant squared. So I'm going to box all those into because those are your other ones. Okay, are you going to use cosine and sine all the time? Yes. Like I still use it when I take my master's courses. Okay, and do you notice how some of them are negative?
Yeah.
Do you see any pattern? How they're, like all the ones that are negative have something in common? All the codes are negative. So cosine's negative, cotangent's negative, cosecant's negative. So like that's kind of a helpful thing to know. So all the codes are negative. If you want me to prove all these, I can. No one wants that. You ready to just do some examples? Okay, now just because you learn trig functions doesn't mean you get rid of all your other rules. So you still have your power rule, you still have your product rule, you still have your quotient rule. You still are going to have to use those. They don't just like disappear. Okay, because all of these have some part of that in them. So like if we do like this first one, so we're gonna differentiate y equals x squared sine x. I'm just on the video. We're good. Okay, so if I have x squared sine x, what rule am I gonna have to use first? The product rule. Because x squared is